Hello, I'm back from my trip. Um, and I did the daily Leetcode. It is November 5th, 2023. And today's problem is called Find the Winner of an Array Game. Okay. And this array. Hold on. Oh, sorry. This array game is a comparison game. Let's look at this example. You have 2, 1, 3, 5, 4, 6, 7. Okay. You have an array and you have a target streak count. Okay. And you're expected to return the number that hits the streak first. So let's look at, we take the first two values in the array, 2 and 1. What's bigger? 2. 2 is the winner, and 1 gets moved to the very back of the array. Two's win count is 1. Let's check 2 and 3. 2 and 3, 3 is greater, so 2 goes to the back, and 3 is the winner. And now let's check 3. 3 and 5, 5 wins. And note that we are resetting the win count right here. So let's see, 5. 5 beats 4, good. And, oh no, 3 loses to 5. 5 is the winner. Win count is 1. 5 beats 4, and the win count is 2. So 5 won 2 consecutive games, and it is returned immediately. So let's look at our my implementation of this. It's not optimal, but is my solution. It beat 5.07%, but it didn't do that bad with memory. So let's take a look at the solution. So we start off with an array list because I want to um, edit the integers, the order of the items, and that's easier with array. I guess I could do it with an array as well, but you have to push everything forward. And that's a hassle. So I convert the array into the array list. We set the streak to 0. Um, we do while streak is less than or equal to k. And what we do here is if streak is equal to k, we want to return immediately. Or if the streak is longer than the list size, that means it'll keep on going in a loop, in a loop, in a loop. And when that happens, we want to just return it immediately because we know the cycle is going to waste time. And this is the other conditional. So if it is greater than the next one, we increase the streak, and we move the second variable to the very end. And in the other case, we would reset the streak instead of incrementing it by 1, and we would move the first variable to the very end of the list. And then this is if it doesn't work. I thought it was going to be binary search related like that other problem we did a couple days ago, but I was wrong. So yeah, this is a solution. I'm pretty sure there's a better way of doing this, so I'm going to check it out right now and get back to you. Okay, so this is the optimized solution, and I'm going to go over it a little bit. It only uses O of n time, or O of, yeah, pretty much, and because it only iterates through the array once. Okay, and what it does is it's pretty much a max finder. So it starts at here, right? It checks if it wins. If it does, then you keep on going. You check the next one. Does it win? No, it doesn't. Now this becomes the current. Okay, now this is our star variable. Does it win? No, it doesn't. So we don't care about any of these anymore. Now we're at 5 and 4. We have a win of 1, right? We check if it wins. Good. It wins. Now it's 2. We return. Okay. And what this does is essentially like ignores the pushing this back to the end, pushing this back to the end. Because once you find the max, the more down you go, and like the more that you the more variables that you skip, the higher the number is going to be, right? We would ignore 4 and go to 6 if k was something higher. And then after that, we ignore this because at this point, if this is the max, then we would just return the max at that point. And it doesn't matter how large the k value is. So that's why this is the optimized solution. It abstracts a lot of the game elements and rules, but it is the fastest way to solve this problem. And yeah, quite a lot. I'm sure quite a lot of thought. So kudos to whoever wrote this, and yeah, thank you for watching today. I'll see you tomorrow.